Hi, welcome back to class. Today we'll be talking about mole concepts. Why is it important for us to study about mole concepts? Okay, because in chemistry calculation, we'll find ourselves looking for the number of moles or using the number of moles to solve a particular question. Now, when you talk about mole, what comes to your mind? Think of a mole as a counting unit. Just like a pair means two, a dozen means 12, a score means 20. So mole is a unit that represents a particular number, and this number is very big and is referred to as Avogadro number. Yes, and the value of this Avogadro number is 6.022 times 10 raised to the power 23. Okay, so this number is very big. You can imagine how big it is. Now, so we can say 1 mole is equals to 6.022 times 10 raised to the power 23 particles. And this particle can either mean atoms, molecules, or ion. Okay, so I want you to see the Avogadro's number as a way we can transition from AMU, which is atomic mass unit, to grams. Okay, the Avogadro's number, which is Na, okay, we refer to it as Na, is a way of transitioning from AMU, which is atomic mass unit, to grams. Okay, it helps us in a way that we don't need to count atoms one by one, but we can count them in moles, which is helpful in measuring when we want to measure any amount in the lab. So let's look at some examples. 1 mole of hydrogen atoms. I believe you can determine that 1 mole of hydrogen atom will contain how many atoms? It contains 6.022 times 10 raised to the power 23 atoms. What if I ask you to find what is in 1 mole of oxygen molecule? So it's going to be also 6.022 times 10 raised to the power 23 molecules. Okay. What if I ask you to find the number of ions in 1 mole of sodium ion? So it's going to be 6.022 times 10 raised to the power 23 ions. What this means is the number of particles is equals to moles times our Avogadro's number. I'm just going to write it like that, okay? So remember that this is the Avogadro's number. Now, which is the same thing as making moles the subject of the formula. It becomes number of particles, and remember the particles is ions, atoms, molecules, okay? So over Na, which is Avogadro's number. So remember the Na is Avogadro's number, which is 6.022 times 10 raised to the power 23. Okay, so anytime you are given a number of particles and you of course you know the Avogadro's number, so you can always get your moles from it. Using that formula, let's solve this question. It says, how many atoms are in 2 moles of carbon? So how do we go about it? Remember that our formula says the number of particles is equal to what? Moles times Na, right? Okay, good. Now, so we're looking for the number of atoms in this case. So the number of atoms in this question is equal to, what's the number of moles we are given? 2. Good. and then times what? Avogadro's number, which is what? 6.022 times 10 raised to power 23. So which is what? When you multiply this, you're going to have 12.044 times 10 raised to power 23 atoms. Okay, and you can also write this very well in standard form. It's going to be, so that means you are going to do this, and doing that, jumping to the left means that you are going to have an additional one. Okay, so which is 1.2044 times 10 raised to power 23 plus 1. Okay, so it's 23 plus 1, so it's going to give you 24 atoms. Okay, very good. Now let's talk about molar mass. Molar mass is the mass of 1 mole of a substance, and the unit is gram per mole. Okay, so what is the mass of 1 mole? That is what we are talking about. What's the mass in 1 mole of a substance? Okay, so for instance, um let's consider water. Okay, let's consider water. How do we get the molar mass for water? First, we need the atomic mass. Okay, and we also need to know the number of atoms, which is always shown in the chemical formula for the compound. Okay, so in this case we have 2 hydrogen atoms and 1 oxygen atom, so you multiply the atomic mass of the particular atom or element times the number of atoms that you have. Okay, so that is 4 hydrogen. We know that the atomic mass is 1 and we have 2 of them, so that is 1 times 2, then plus 16, which is the atomic mass, and multiplied by 1. So this is 2 plus 16, and that gives us what? 18 gram per mole. Okay, now let's consider that of calcium carbonate. Okay, so the atomic mass for calcium is 40, the atomic mass for carbon is 12, and the atomic mass of oxygen is 16. So we have 40 times 1 plus 12 times 1 plus 16 times 3. Okay, so this gives us 40 plus 12 plus 48. Okay, and altogether that gives us 100 gram per mole. I believe we now understand how to calculate molar mass. Now that we have established that mole is very important in our calculations as chemists, we need to understand different ways that we can get our number of moles depending on what we are solving and what we need to get. Okay, so now I'll take you through different ways to get our number of moles. So the first one is what we have established in the beginning, which is moles is equals to number of particles. I'm going to represent number as NO, number of particles over Na, which is the Avogadro's number. Remember I told you that number of particles is equal to moles times Avogadro's number. So just making this the subject of formula, then we get. Another way is relating it to mass and molar mass. So moles is equals to mass of a substance. I'm going to stop here. Okay, over molar mass of that substance. Okay, then another way to get the number of moles is if it is for a gas. Okay, if you are considering a gas, you can get the number of moles by saying volume of a gas over volume at STP, and this is the same thing as volume of a gas or a substance over 22.4 dm cube, which is the same thing as volume over 20. Now, another way to get the number of moles when you have the solution is Moles is equals to concentration times volume. So there are other ways to get the number of moles, but these are the ones that I will be taking you through for now. So let's look at examples. Here are some questions for us to do, and let us see how we can calculate the number of moles in this question. So the first question says, a sample contains 3.01 times 10 raised to the power 23 atoms of copper. How many moles of copper atoms are in this sample? So this question, we can see that we are given the number of particles, which is 3.01 times 10 raised to the power 23 atoms, and we are asked to find the number of moles. Definitely, we know the formula we are going to use, and the formula is what? Moles is equals to number of particles over Avogadro's number. And the question gave us 3.01 times 10 raised to the power 23 over what? 6.022 times 10 raised to the power 23, right? Okay, we have, if you just do this in the calculator, you can see this are the same, so you can always cancel them out. And you have 3.01 divided by 6.022. So this is approximately 0.50 moles. Okay, so and that is our answer. Now let's solve the second question. It says, how many moles of helium gas are present in 6.022 times 10 raised to the power 24 atom sample of helium? So let's go. It says that we also know the formula we are going to use, which is what? Moles is equals to number of particles, right? Over Avogadro's number. According to this question, this is equals to, right? And our Avogadro's number is exactly. Okay. So in this question, I like it because it helps us to apply a lot of indices. If you have not watched my video, I have a video of a lot of indices. So now we can see that this one and this can cancel out because they are the same. And we have 10 raised to the power 24 and 10 raised to the power 23. So we have the same basis but different powers, right? So, and we have the division, which means we are going to subtract the power. So this is 10 raised to the power 24 minus 23 and get 10 raised to the power 1, which is equal to 10. So the number of moles of helium atom is 10 moles. Now, question 3, it says that a student weighs out 36.0 gram of H2O. Given that the molar mass of H2O is approximately 18.0 gram per mole, how many moles of H2O did he weigh? So we have what in this formula? We have mass and we have molar mass. So we know the formula to use, which is what? Moles is equals to mass over molar mass. And this question has already helped us by giving us the molar mass. So we just have to impute the values, which is 36.0 gram over 18.0 gram per mole. Okay, and the answer is what? 2 moles. So you weighed 2 moles of water. Now let's solve question 4. So the question says, how many moles of CO2 are in 11 gram sample? How many moles of CO2 are in 11 gram sample? And we have C is equal to 12 and O is equal to 16. We already know that we have to calculate the molar mass and we have been given the mass. Okay, so moles is equal to what? Mass over molar mass. So let's quickly calculate the value for the molar mass of CO2. So that is 12 times 1 plus 16 times 2, and that is what? 12 plus 32, which is 44 gram per mole. Okay? Yes. So now, getting our number of moles will that be? Moles is equals to mass that we were given is 11 gram over the number of the molar mass is 44 gram per mole. And when you do that, you get 1 over 4, which is the same thing as 0.25 moles. So, yes.
Pause the video, attempt the question, and let me know your answers in the comment section. I'll be there to help if you get stuck or have any questions. If you found this lesson helpful, don't forget to subscribe to the channel, give this video a like, and share it with your friends and anyone else who might benefit from it. I'll see you in the next class. Bye!